Hi there, mathematicians. Welcome to our last section of Chapter 9, Solving Right Triangles. Our objectives are to use the inverse trigonometric ratios to solve right triangles. So our essential question, when you know the lengths of the sides of a right triangle, how can you find the measures of the two acute angles? Let's start with our first example, identifying angles from trigonometric ratios. Determine which of the two acute angles has a cosine of decimal 5. So now that we've covered all three trig ratios, we're focused on the one for the cosine. So find the cosine of both angles A and angle B. Those are your acute angles of this right triangle. Let's start with the cosine of A. And remember, cosine is the ratio of adjacent divided by hypotenuse. And it's always adjacent to whatever angle you're figuring out. Or that is your theta angle. So for theta angle A, we want square root of 3, which is adjacent. So here's A. So my adjacent leg is square root of 3, divided by hypotenuse, which is 2. Type this fraction in your calculator. So square root of 3 divided by 2, hit enter, and you should get this decimal value. Decimal 8660. Now let's find the cosine of B. Also adjacent divided by hypotenuse, but this time it's from the perspective of angle B. So adjacent would be 1, and then divided by hypotenuse, which is 2. So 1/2 simplifies to decimal 5. So it looks like angle B is the one that results with the cosine being decimal 5. All right, so let's take a moment and just talk through how to find missing side lengths and how to find missing angle measures. All right, make sure that you're using your decision flow chart to help you decide how to find missing side lengths. And it's definitely dependent on what's given. So always make a list of what you're given and then start following the decision chart, answering questions with yes and no. When you get to the decision about whether you're given one side and one angle, do always check for special rights. And remember, you must see the labels of either the 30 degrees, the 45 degrees, or the 60 degrees to actually use your special right ratios. And then, of course, we now have our new trig functions. Now, to find missing angle measures, you would use your trig inverse functions. Also, see decision chart. You have your three different inverse functions. The inverse of sine would be sine inverse of opposite divided by hypotenuse, cosine inverse of adjacent divided by hypotenuse, and inverse of tangent of opposite divided by adjacent. You can find all your inverse features within the menu of your trig on the calculator, and just remember your inverse symbol is this power -1. We read, like this right here would be read, the inverse of tangent of x. All right, so let's just take a moment to practice finding the inverse of all of the following situations. So we have tangent of A is unknown, equals decimal 75. And remember, your ratios can be in the form of decimals. So here we don't have the fraction of opposite divided by adjacent, but it's already been simplified to a decimal. So when you type it in the calculator, simply type in tangent inverse of decimal 75, hit enter, and you should have gotten 36.8699. All right, so the rest of these would be inverse sine of decimal 87, hit enter, should have gotten 60.4586. Do cosine inverse of decimal 15 for part C, and should have gotten 81.3731. So measure of angle A comes out to be approximately 36.9 degrees. Measure of angle B comes out to be 60.5 degrees, and measure of angle C comes out to approximately 81.4 degrees. All right, let's look at this example where you're finding the measure of angle A to the nearest degree. So look at what you're given in relationship to the angle. So angle A is our theta angle. Make a list of all your parts. So we have, in relationship to angle A, we have the opposite, and we have the adjacent values. So that means of our options, SOHCAHTOA, we're going to be using tangent. So opposite divided by adjacent. So write out your equation. So tangent of A equals opposite divided by adjacent, which is 15 divided by 20. So since we don't know the measure of angle A, we have to do inverse tangent of the 15/20ths. So type that in your calculator. And the measure of angle A is approximately 37 degrees. All right, now you try this one. And remember, make a decision about what parts you're given in relationship to the degree of the angle that you're trying to find. And label all your parts and make a decision. Follow your decision chart. So pause the video here and finish the rest of this on your own. All right, did you get the angle measure is 29 degrees? If not, pause here, look at the work, see how it compares to your work to see if you can identify your error. All right, so based on what we've done so far, let's just establish one core concept in this particular section of Chapter 9 to solve a right triangle. So when you see this verb, what it means is that you're finding all unknown side lengths and angle measures. So you can solve a right triangle when you know either of the following: 2 side lengths or 1 side length and the measure of 1 acute angle. Remember, our decision chart helps us figure out which strategy we need to use in order to find all the unknown parts. All right, so let's practice solving all the parts on this given right triangle. Quick reminder, use your decision chart to help you decide what methods to use in order to solve for the side lengths and angle measures. Let's start with side C. Looks like for side C, we know 2 out of the 3 sides. Well, that means we're going to use Pythagorean theorem. So my first step is to write out my formula for Pythagorean theorem, substitute the parts that I know. So I know my 2 legs, so 3 and 2 go in for A and B. Work this out, so 3 squared is 9, 2 squared is 4, 9 plus 4 is 13. I've got c squared equals 13, so I've got to square root both sides. So I end up with c equal to the square root of 13. Type in square root of 13 in the calculator, and I get approximately 3.6. If I were to leave it as exact, I would leave it as a radical. If I want to approximate, I type it in the calculator and get a decimal value that I round. Next, let's look at angle B. We know that the opposite and adjacent sides are given, so that means I can use tangent inverse to help me figure out the measure of angle B. So I type that in the calculator and I get 33.7. Now the remaining acute angle is the complement of angle B. So all I have to do here to get angle A is subtract what I figured out for angle B from 90, since they're complementary, and that gets me the measure of angle A, which in this case would be 56.3 degrees. And you could have definitely switched the order of figuring out angle A and B. In other words, you could have figured out angle A also using inverse tangent, but it would be inverse tangent of 3 divided by 2, and then get the complement of angle A in order to get angle B. So the order in which you figured out angle A and B doesn't matter. All right, see if you can do example 4 on your own. Try to find all the missing parts, so side G and side H, and the measure of angle G. All right, side H, you can use angle H, because we know opposite and hypotenuse. So sine equals opposite divided by hypotenuse, so set up your equation. So did you get a H value of 5.5 approximately? And then for side G, should have gotten approximately 11.8. So check over your work, compare it to the work here, and see if you can identify your mistake. Here's just an extra example for you to include in your notes to reference. It's good to have as many examples as possible to just kind of help clarify all the different possibilities for setting up your trig functions in addition to solving for all the unknown parts. So take a moment to copy down all this work so you can have an extra example in your notes. And definitely think through all the different steps, following your flow chart, decision chart, as well. All right, I want you to pause the video here and try this extra example on your own. Start at the very beginning of your decision chart to help you decide answers to your questions and decide which method you would be using to solve for all the unknown parts. All right, so the very first decision you probably made was using the Pythagorean theorem to find that missing hypotenuse h. All right, so your h value should have come out to be 2 square root of 146. And you can always type that in a calculator and get your approximate decimal value as well. And then for our measure of angle C, you should have gotten 66 degrees. So look over the work here. Measure of angle B first, which is 24 degrees. Then the complement of measure of angle B is the measure of angle C, which is 66 degrees. So check over the work here and see if you agree. And then here are the labels you should have put on your picture to kind of help you decide which trig ratio to use to find the measure of angle B. All right, for this, try this on your own. I'm going to check your answers when you come to class, when I check over your notes. So go ahead and take time to work this one out, but I just won't reveal answers to you through the video. We'll look at it together in class. All right, our last example, a real-life problem. Your school is building a raked stage. The stage will be 30 feet long from the front to the back. So that's going to be this length right here, with a total rise of 2 feet. You want the rake, which is your angle of elevation, to be 5 degrees or less for safety. Is the raked stage within your desired range? So that means we're solving for this x. Your angle of elevation is right here. So it looks like the parts that were given in relationship to our angle is our opposite and hypotenuse. So that helps us with our setup. So look at your decision chart to know how to set up the problem, and take a moment to pause here and set up your problem. All right, so it looks like we're setting up our sine equation. So sine of x equals 2 divided by 30. To solve for this unknown angle measure, we're going to have to use inverse sine ratio to find the degree measure of x of the rake. All right, so you type in your calculators, inverse of sine of 2 divided by 30, which comes out to approximately 3.8. So the desired degree value of the rake is within our desired range, that is 5 degrees or less. All right, and that's all for today's video. That concludes all of Unit 9. And I wanted to leave you with this round kick from a giraffe to another giraffe.